So let's talk a little bit about cloud computing.
Leadership is about to create future leaders, not followers.
Architectural response is to replicate information not only in data centers, but among data centers or across data centers, and potentially even across clouds.
The big opportunity with cloud computing is lower cost.
Well, for those people who really want to think in a more far-out way, I will say that the interplanetary extension of the Internet is well underway. It's on board the space station, it's on board the equipment we have in orbit around Mars and on the surface of Mars. We have one platform called Epoxy, which is in orbit around the Sun. We have International Space Station operations. So this is beginning to happen. So during the remaining decades of the 21st century, I anticipate that we will see the accretion of an interplanetary backbone that will help support manned and robotic space exploration.
Scale changes everything. And so understanding that to generate the kind of scale that we see in big data, that we're seeing in cloud, you have to think deeply about the detailed structure of the systems that we're looking at, think deeply about the algorithms that are being used so that they can run efficiently over a very broad range of applications, because cloud expects a very broad range of applications.
If you're really in the leadership position, whether you're in the academia or you are in the industry, your job is not to create followers. Is to create leaders that can think about these complex problems, can solve these complex problems.
Yeah, one of the nice things about OpenFlow is that it says, great, now I can write a program that controls my network. But if I can also write a program that controls your network, then that's potentially a major security hole. But in addition, there's the challenge of isolation. It's very important that if we are combining multiple OpenFlow rule sets on a single switch on behalf of multiple different users, that if one of those rule sets uses the switch in a way that it wasn't expecting to be used, that can actually really impact other traffic that's moving through the switch. Even if the user wasn't malicious, it puts new stress on the switch designs and the software in the switches and firmware in the switches to really maintain isolation amongst all of those different really programs now that are running within the switch.
Well, if you're talking about humanitarian efforts and you're talking about the access to information, the cloud computing can provide that in a very low-cost way, and I think that could be a real benefit in areas, many areas around the world, but areas like Africa where we have some focus at the moment, or it could be Haiti, for example, where we needed those access to information is often critical through various stages, whether it's a crisis or whether it's an ongoing humanitarian effort.
Short of a planetary disaster, like the strike of an asteroid or something, I am very interested in how you recover from major catastrophes. These could be natural problems, earthquakes, hurricanes, and things of that sort, or they could be man-made. But they all have the potential effect of stopping the basic infrastructure from functioning in the way that we rely on. Anytime infrastructure goes away, it's almost always quite damaging. So the way I think of architectural response is to replicate information not only in data centers, but among data centers or across data centers, and potentially even across clouds. One of the issues that arises is longevity of the information. How long can I make it accessible? An example of a kind of man-made catastrophe would be somebody losing all their keys and not being able to unlock the data that's sitting in the cloud operator saying, don't look at me, I deliberately didn't keep any of the keys because I assumed you didn't want me to get into your data. You can imagine, though, creating third-party operations that will preserve key-based knowledge so that if everything goes away, you still have the ability to get access to data that was replicated in one cloud or another.
At the academia level, I would say that we have to rethink the way we educate our engineers. We are not educating them in terms of writing better software code. They go get a bachelor degree from universities from great universities across the globe, but when they go write codes, the code has a lot of flaws in them, and those flaws are the ones that are easily hackable by these hackers or thieves, cyber thieves across the world. So you need to have to change the way and the method in which you would teach. And I would say, focus not just on writing software code, but have them solve the system engineering problem of the code itself, and then write the code on top of it and continue to do testing would be my strong recommendation, because we have to solve this security problem, which if we don't solve it as an industry will end up to be a problem of what I call the biblical proportion within a decade.
Well, this is both a personal observation and an observation for people, especially young people beginning their careers. The internet isn't over yet, in spite of the fact that it was designed in 1973, nearly 40 years ago. It continues to evolve. It continues to expand its capacity and its footprint. It continues to surprise, as in the mobile access to the net over the last decade. So this means that there are ample opportunities for people to contribute to an evolving internet.
Data is one of the most valuable assets available in the cloud, and it will increasingly be one of the assets that's provided as a service from the cloud. And people should keep an eye on the movement towards open data. So just as we've gone through open source software, and it's made a fundamental change in the way people think about how they can build systems, we're starting to see open data, data.gov, cosm.com, and a large variety of other systems.
It's not a static thing at all. It's almost organic in its character. And it has grown in an almost biological way. People go and build pieces of internet, and then they find somebody to connect to. People build applications sitting on top of web-based platforms, and these propagate in an almost viral fashion. So this is more like an ecosystem than it is a rigid design. It's a very loosely coupled environment, which is what gives it its vitality and its ability to evolve. And so you could do worse than to go into a career looking at network-oriented computing, programming, and system development.
People are sharing data so that not only, well, as we saw in software, a wide variety of people can contribute, but in this case, a wide variety of people can analyze the data, come up with new insights, perhaps integrate it with data that others haven't thought of, and essentially develop new insights and services for technology that we can't imagine today.